Video problem 89, more pH scale work. This is going to be very similar to 88, except now we're dealing with bases. Okay, so it gives us a pH of 8.25. Now let's take a look at this. This B minus is a base. So when I throw it into water, what's it going to do? Well, it's a weak base, so it's going to be in equilibrium with Hb, the molecule, plus hydroxide. Okay, what does a base do? A base accepts a hydrogen ion. So there you go. So that means my Kb is going to look like this. And we know that that is equal to 1.78 times 10 to the negative fifth. Okay. And then we know that our ice table is going to look like this. Again, we're looking for the molarity of the base, so we don't know what that initial molarity is. So I'm going to have Hb, OH minus, and B minus. So these are both 0. This is Y. We don't know what that is. That's what we're looking for. It's going to go up, up, down, X, X, and then it's going to be Y minus X. Okay. Where X is the concentration of hydroxide, and I can figure out what that is from the pH. So I'm going to solve for the pOH first. So I get a pOH of 5.25, and then I can calculate the OH, 10 to the negative pOH. Oh, I said 5.25. It's 5.75. Sorry. Okay. So I get a value of a very small number, 1.78. 778, we'll say, times 10 to the negative sixth. So that's the molarity of the hydroxide. That means I know this number, and this number. They're all 1.778 times 10 to the negative sixth. So I can plug all that in. Yeah, we're fine. Alright, so let's see what we get. Let's square that value. I end up with a 3.16 times 10 to the negative 12th is equal to 1.78. Whoops. 1.78 times 10 to the negative fifth. Y minus multiply those two values. And I get minus 3.165 times 10 to the negative 11th. So I'm going to add that to both sides. So let's take that really small number and add that really small number. And so I get 3.481 times 10 to the negative 11th is equal to 1.78 times 10 to the negative fifth, Y. Okay, so I'm going to divide that by 1.78 times 10 to the negative fifth. Negative value of a really small number, 1.956. If I do it to 4 sig figs, I shouldn't, but I'm going to, times 10 to the negative sixth. And that's molarity. Why is that? Okay, thank you. Which is my concentration of B minus, which seems pretty small. The pH is pretty close to 7, so it makes sense that it's a fairly low molarity. The higher the molarity of the base, the higher the pH. So yeah, that makes sense. I think that's a good number. Okay. Now just a little tip, sometimes here where I identified hydroxide, sometimes I also want you to put that that's the HB as well. So sometimes you need to explicitly state that you know that both of those values are the same. I think we've done that here, but never hurts to be careful. Here's a little bit about caffeine. It has a pH of 10 and a Kb of 4.1 times 10 to the negative fourth. Right, so let's look at what caffeine does. Right. Now, just like any good base, it's that's plus water, not plus hydroxide. Just like any good base, it's going to steal a hydrogen ion. So we're going to end up with HC8, H10, N4, O2 plus hydroxide. Okay? So again, just go ahead and pause it, see if you can solve it, and then I'll show you the answer. Alright, so here's the answer. From the pOH, we can calculate the hydroxide, and I got the pOH by 14 minus 10. Right, so that's how I got 4 there. So that gives me 1 times 10 to the negative fourth for my concentration of hydroxide and the conjugate acid. Right. So here we go. I plug those in. There, there, and there. So I end up with a value of 1.24 times 10 to the negative fourth molarity. Now I didn't show the ICE table. You definitely want to show the ICE table all the time.